GitFlow is dead.
What?
Yes, you heard that right. GitFlow is dead, or rather it is dying. And the reason is simple. It's because it is slow. And it is being replaced with something called trunk-based development. In this video, we will talk about why GitFlow is dying, how the replacement trunk-based development works, and in the end, we will talk about feature flags. Why is GitFlow dying? Let's answer that question. Most of you work with cloud and have CI/CD set up in your corporations. If not, you will soon, because most of the corporate world is moving towards cloud. Let me ask you this. What is your release cycle? Does once in a quarter, once in 2 months, or once in a month ring a bell? Do you know what C in CI/CD stands for? Continuous. How is delivering once a month continuous? It's not. This is in part due to GitFlow workflow. Because remember, every time you want to create a new feature, you create a new feature branch. Then you work on this feature in this feature branch till the requirement is finished. And this can sometimes take days or even weeks. And this is not continuous integration because only after the work is finished, a pull request will be created and then this will be merged back into the development branch. And similar is the story when it comes to delivery. Every time we want to create a new deployment, a new release branch is created. This branch is then tested and then finally released and then merged back into master, and the story goes on, which is a slow process, and it automatically creates a culture of non-continuous delivery and non-continuous integration. That's why trunk-based development is taking over. It is slowly, or rather quickly, becoming the de facto practice in DevOps teams. Trunk-based development has been around for 20 years. Google and Facebook today practice trunk-based development and have contributed to making it popular. Can you explain what trunk-based development is? Let's talk about what trunk-based development is. The main feature of trunk-based development is that there is only one branch, and that is called trunk or main branch. The second feature of trunk-based development is that there may be some short-lived feature branches. And by short-lived, I mean they are created on the same day, worked on, reviewed, and merged back to the trunk or the main branch on the same day. This will promote smaller and cleaner commits. Why is that important? We will see later in the video. The next feature of trunk-based development is that every merge that happens into the trunk or the main branch is quality controlled not just by the pull request but also automatic code coverage and integration tests. So it is imperative that you have automatic tests set up before you start using trunk-based development. But most feature branches are not finished in one day. How can I commit incomplete changes into the trunk branch? That's a relevant question, and the answer is feature flags. Feature flags are also known as feature toggles, which are nothing but a switch which is by default off. And all your code for this feature is in an if block on this switch. This way you can even push your half-finished feature code to production without affecting the scope or the quality of the release. And once the feature is tested successfully on the staging environment, which you can do by switching the switch on the staging environment, you can change the switch to on also in production. But remember, after a feature goes live, you should always delete that if block so you do not have any junk code, and also delete the switch. Let's look at feature flags in action using a tool called Togglz. There are of course other tools like Unleash and FF4J. The links to all these tools will be down in the description. Here we have a very simple Spring Boot project which uses Spring Boot Starter Web. So I have some REST controllers that I can use for testing. To begin with, I have a simple controller called foo, which does nothing more than returning a string foo. Let's say the next feature is called bar and we want to implement it using feature flags. So the first thing you need to do is integrate Togglz in your project. To do that, we go to our POM file and then we add Togglz Spring Boot Starter, which will auto-configure Togglz for you, which is really cool. You can also add an optional Togglz console dependency, which is highly recommended, which you will see in a minute why. Once you have done that, you can go to application.properties and simply define your new feature by name called bar. The property is called toggles.features. The feature name, which is bar.enable, and by default it will be false. Now we will go and implement our bar controller. Because Togglz is auto-configured, something called feature manager is automatically available to us. We can auto-wire it using the constructor, and after that we can say manager.isActive bar and then put it into the if block, and if it is not active, we throw an unsupported exception. Let's look at it in action using the browser. I've started my server. Let's go to our first controller endpoint, that is foo. You can see the expected string foo. Now let's go to our second endpoint bar. As expected, you see an unsupported operation exception. Now let's switch on this feature. That's where the Togglz console comes handy. This is the link to the Toggle console. As you can see that the feature bar is disabled. By clicking on the button disable here, I can enable this feature. Once the feature is enabled, let's go back to the bar URL again and see the result. And you can see that it's working. Let's talk about console for a minute. For the demo purposes, I have disabled all the security. But of course, in a real environment, you would want admin to be available only to certain users with proper rights. And the coolest thing about feature flags is that it is not just on and off. If you click on the settings button here, you can see that there are different activation strategies like gradual rollout, header, IP address for client, IP address for server, some JavaScripting, query parameter, release date, server name, and different things. So you can use feature flags not just to disable some features while you're ready, but you can do gradual rollouts, you can do A to B testing, you can do basically anything imaginable. And these strategies are not just limited to the ones that I mentioned here. You can virtually create your own strategy with any kind of logic you want. If you want an extensive tutorial on the libraries or the tools that I mentioned, please leave a comment. Now let's go back to trunk-based development. If you now combine having just one trunk branch, short-living feature branches, automatic code coverage and testing, and feature flags, what you get is real CI/CD. You can now integrate your changes every day, even multiple times a day, into the main or the trunk branch, so you get continuous integration, and you can deliver every day, even multiple times a day, leading to continuous delivery. What about hotfixes? How do I fix a production problem without having a master branch? That's a good question, because we deliver every day. The status of the production never really deviates much from the main or the trunk branch, and everything new that comes in is anyway secured using the feature flag, so it is not enabled on the production. So all you have to do is go to the trunk, fix your bug, and deliver next time. So you do not really need a master or a hotfix branch. What about versioning, and how do you create a release? For versioning, just stick to semantic versioning. Let's look at an example. Let's say the version in production right now is 5.3.0 minus 11. 5 being the major version, 3 the minor, the 0 the hotfix version, the patch version, and 11 being the iteration. The version of the trunk at this time should be 5.3.0 minus snapshot. Let's say your delivery cycle is once a day. The next delivery packet that will be created using your build script should have a version 5.3.0 minus 12. And then the day after, minus 13 and minus 14 and so on, assuming that the only software change that is between these packets and production is the code that is in these feature flags. So basically the scope of the production has not changed. Let's say after the iteration 14 was deployed, there's a need of an hotfix. What you could do at this time is change the trunk version to 5.3.1 minus snapshot, and then the next build that will be there will have the version 5.3.1 minus 1 and so on. Now let's say sometime in the future your features have been tested on the staging and are ready to be released. That means that the if blocks for the feature flags are removed and the feature flag is deleted itself. So at this time, the version on the trunk can be upgraded depending on if it is a breaking change, then it could move up to version 6, or if it's just a minor change, no breaking change, then it could be a minor release with version 5.4.0. Let's do a quick recap of the video. We saw how GitFlow is slow, actually rhymes, and is antithesis to cloud-based development, CI/CD, and DevOps culture. Then we saw what trunk-based development is. We also looked at feature flags and how they complement trunk-based development. We also looked at Togglz to see a demo of how feature flags can work. We also talked about how hotfix and versioning can work in trunk-based development. To be honest, if you're not using cloud and don't have CI/CD set up and have rigid release cycles, then you should probably still use GitFlow. Otherwise, you should really think about moving towards trunk-based development. That's the end of the video. Thanks for watching. Like and subscribe.